Dear students, now we are going to see bivariate and multivariate analysis. Bivariate analysis involves to analyze two variables or factors for the purpose of determining its relationship between these two variables. For example, A and B, there are two variables you are going to measure its relationship. You can use bivariate analysis. There are different techniques or methods of bivariate analysis. Now we are going to see only three methods under bivariate analysis, that are correlations, regressions and scatter diagram. The correlation measures the linear relationship between two quantitative variables. For example, height and weight are these two variables. In order to measure its relationship, we can do correlation. Under this information, you can see two types of two effect of correlation: positive effect as well as negative effect. A positive effect shows if one variable increases, at the same time another variable will also increase. It's called a positive correlation. See the two axes x and y. If y increase, if the y increases, x is also increase, is called as this relationship is called as positive correlation relationship. When we see the next picture, y is going to increase. At the same time, in the x side, the impact will be decrease. When the y is increases, x is decreases, is called a negative impact of correlation. Next is regression. It is a process of estimating relationship between dependent variable and one or more independent variable. Dependent variable is outcome based. Independent variable is predictor based. For example, now I am going to explain what is dependent, what is independent. There are two variables we can take now: height and weight. Age and height. What is dependent variable here? What is independent variable here? Height is a dependent or age is a dependent? Height is a dependent. Depend on age, height will change. So height is a dependent variable. Age is a independent variable. Age is not dependent on height, but height is dependent on age. So in order to know the relationship between dependent variable and more than one independent variable, so not only age influence height. Apart from age, there are some other nutrition factors also induce nutrition factors, heredity factors. These are some other factor, not only one factor. Apart from one or more than one, some other factor will also influence the outcome. That relationship you can calculate or identify through regression. The purpose of conducting regression is to predict the outcomes, forecasting the outcomes. We can identify the relationship between independent and dependent factors. So these are things we can identify through regression. Third type of bivariate analysis is scatter diagram. Here also we can identify the relationship between two factors. But in scatter diagram, we can determine how closely these two variables are related. In this slide, you can see there are four different type of graph you can see in this slide. The pattern of intersection of points in each graph is vary. In first graph, if you are seeing the first graph, it shows if one variable will increase, another also increase. But in the second slide, you can't easily identify the relationship pattern. If you are going to compare y and x, if you are going to compare y and x, you can't easily predict what type of relationship here variables are having. So that's what because of that reason this scatter shows moderate relation. This scatter shows positive or strong relation. See the third one. Here there is no relationship between these two variables because the scatters are highly deviated with each others. So we can't identify the relationship between x and y. But here there is no linear relationship between, compare with this slide with fourth slide. In the fourth slide there will be some straight relationship between x and y. So in first slide there is a linear relationship between, straight relationship between x and y is there, but here there is no linear relationship. First it will increases and then it will be decreases. That means first it has a positive relation. Second, after it will go to the high level, it will decline after that. That is opposite. What experience we had initially, it will be changed later on. So all variables comes down. In y-axis, variables are decreasing, but in x-axis variables are increasing. So there is no straight relationship between these two variables. Initially it is increase, later on it is decrease. Due to that reason, it is non-linear effect. So this comparison we can do with the help of scatter diagram. Second method is multivariate analysis. In bivariate, we can compare two variables impact or outcomes. But in multivariate, we can analyze or observe more than one variable's outcomes at the same time. At a single time, we can analyze more than two variables. We can go for do multivariate analysis. There are so many types of multivariate analysis we can. So these are 5 types of multivariate analysis we can use to identify the relationship or outcomes of 2 or more variables. The types are: first one, factor analysis. In order to reduce the number of variables into few number of factors, we can use factor analysis. For example, in our home, every month we will prepare a grocery list. This list has n number of items. There are so many variables in this list. It can be grouped into different factors like nuts, rice items, flour items. Based on this factor, we can group all variables into different categories. That is factor analysis. I think you may understood about you can understood about my example. In order to extract the maximum variance from the all variables and put it into some group, that is score, we can use factor analysis. For example, these are different variables. See here, we are going to measure the competency. These competency characters are there are n number of competency characters. It will be grouped into different factors or indexed. For example, knowledge, skill, clinical skill, reasoning skills, procedural skills, medical knowledge. So this right side variables are grouped into four factors or four factors. So in order to minimize the number of variables into some number of groups, we can use factor analysis. Second multivariate analysis is conjoint analysis. It is nothing. Consider jointly the effect of individual attributes of a product. In order to identify the individual character of a product or brand, we go for conjoint analysis. So, for example, any marketer, they want to evaluate their product or their brand customer perception, how customers are feel about their product or brand. That can be identified through perform a conjoint analysis. So these are its uses. We can break down the customer utility, because every customer needs are differ. Some customers like its flavor, some customer like its color, some customer like its design, some customers like with its price. So it can be measured through conjoint analysis. With the help of conjoint analysis, a marketer or manufacturer can make an effective plan and design of their products. With the help of conjoint analysis, the complexity of customers' needs can easily understand by the marketers, as well as the differentiation in the market. Take India, we geographical wise, religion wise, we how to tell, we are differentiate ourselves with religion wise, geographical wise. This differentiation can be managed through conjoint analysis outcomes. For example, see here, in conjoint analysis, you are going to analyze various laptop brands. Which of this laptop would you choose? This question we are going to ask with laptop customers. See, there is a matrix, L-shaped matrix we are going to use. The first column is brand of laptops. First row is the first column is not brand. The first column denote what to tell, configurations. Configurations are characters of a laptop. The first row consists of different brand laptops. The first column, as I said already, the first column consists of characters, processor character, RAM character, monitor size, price. These are characteristics of a laptop. According to three brand, the character will be changed. Price, even from price, monitor size, RAM, all are differ to brand. So this can be evaluated. This can be identified and this can be analyzed through conjoint analysis. Third multivariate analysis, discriminant analysis. In order to study or measure the differences between groups, we go for a discriminant analysis. For example, the groups of objects may be individuals or people or person or any firm, whatever it is. In order to identify the differences among the people, differences among the firm in the industry, various firms in the industry, that we can identify or we can study through discriminant analysis. Based on its classifications, we can identify its differences through discriminant analysis. In discriminant analysis, we can determine which predictor variables are related to the dependent variables. That means in discriminant analysis, we can identify what factor will induce the outcomes of the variables. That can be identified through discriminant analysis. There are two types of discriminant analysis we can use. Two groups, in three groups or three or more groups, we can use different type of discriminant analysis. In two group discriminant analysis, the dependent variable is called as dichotomous variables. But in three or more group discriminant analysis, the dependent variable is called as multi-dichotomous variables. Fourth multivariate analysis type is multiple regression. When we want to predict the value of variables based on the value of two or more other variables, we go for use or apply multiple regression methods. The variables we want to predict is called dependent variable. The variable we are going to use to predict the values of dependent variable is called as independent variable. So simply tell, in multiple regression, in order to predict the value of variable based on the value of two or more other variables. In order to predict one outcome based on the outcomes based on the values of two or more variables, we can do, or we can uh, use multiple regression. Simply tell, here I want to code one example for multiple regression. If you want to predict the outcome of the performance of a particular player, in order to improve the outcome of a particular player, there are so many practice he need to do. There are so many steps, or there are so many activities a player need to perform daily or practice daily to get better outcome or improved outcome. So during that type of situations, or knowing outcome of that type of situations, we go for do multiple regressions. In order to know the outcome of one variable based on the influence of two or more variables, we go for multiple regression. But in multiple correlation, it used to measure how well a given variable can be predicted using a linear function of set of other variables. As I told already, linear functions. How one variable can influence the functions of other variables. How one variable influencing the functions or effect of other two or more variables that can be identified through multiple regressions. For example, rain is a single variable. Due to rain, what outcomes it create to sellers, that means vendors, farmers, street sellers, that can be identified or evaluated through multiple regression methods. Due to rain, farmers can cultivate more outcomes. That means more crops output they will get through rain. But road sellers, they will be heavily affected due to rain. Their sales will be reduced due to rain. So this type of different outcomes of a single variable can be identified through multiple regression. Thank you.